can't believe the day of Monica's concert is finally tomorrow.
Wait, what? You're not going to any concert tomorrow?
Yeah, I am. I've been planning this for 19 days of the month.
No, you have a test on the 20th. You're not going anywhere, Missy.
A test on what?
Radioactive Decay.
I don't even like Radioactive Decay. I don't understand it.
Well, I can teach you. I'm a chem major.
Okay, Mom. So, Mom, what is radioactive decay?
Radioactive decay is a process by which a nucleus breaks down into another nucleus and also produces an additional particle.
Can you give me some examples? Like, I know the terms alpha, beta, gamma, but I'm not really sure what they mean.
Whoa, one at a time. Let's start with alpha decay. Okay, so why don't you pick an element that I can start with?
How about neptunium?
Okay, so neptunium's mass number is 237, and then its atomic number is 93, and its symbol is Np. Okay, so in alpha decay, when the atom decays, it forms a helium nucleus. So it has a mass number of 4 and then an atomic number of 2, and then it forms another nucleus, like I said. So to find this one, you subtract 4 from this, so that would be 233, and then you subtract 2 from that, and you get 91. So now can you look at your periodic table and tell me what element has an atomic number of 91?
Is it proactinum?
Yes, and has the symbol Pa. And there you go, you have alpha decay.
Wait, so what other types of decays are there?
Okay, so we also have beta decay. Now, can you give me an element that beta decays?
Why don't we use our previous element, proactinum?
Okay, we can use that. And so its mass number is 234, and then its atomic number is 91, which always stays the same. Okay, so then with beta decay, you release a beta particle, which is an electron. So it has a mass number of 0, and then its atomic number is -1, and you have an E right there. That's your beta particle.
That's the electron, right?
Yep. And then to find the nucleus, all you have to do is subtract 0 from 234, so it's still 234. And then you subtract -1 from 91, but then when you subtract a negative number, you add it, so it becomes 92. Now can you tell me what element has the atomic number of 92?
Uranium has an atomic number of 92.
And its symbol is a U.
Wait, there's also positron emission, right?
Yep, so our next one is, can you give me an element that decays with positron emission?
How about fluorine?
Good choice. Okay, so fluorine has a mass number of 19 and then an atomic number of 7. Okay, and then when that decays, it produces a positron particle, which has a mass number of 0 and then an atomic number of +1, and you write it like that. And then to find out which nucleus it produces, you subtract 0 from 19, so you get 19 again, and then you subtract 1 from 7, so you get 6. Can you tell me what element has an atomic number of 6?
That's oxygen.
Yep, that's an O, and that is positron emission.
Wait, so what's the next type?
Okay, so next we have electron capture. Now can you give me an element that decays with electron capture?
I'm gonna pick a random one. Let's use californium.
Good choice. So californium has the letter CF, and its mass number is 241, and its atomic number is 96. And then with electron capture, the electron is on the reactant side, so it's 0, -1 E, and that is your particle. And
Oh, that's a beta particle.
Yes, but make sure you notice it's on the reactant side, not on the product side.
Okay.
And then to find out the nucleus that it produces, you subtract 0 from 241, so you get 241. And then subtract -1 from 96. I'm sorry, you add -1 to 96 until you get 95. And can you tell me what element that is?
That's americium.
And that has a symbol Am.
What about gamma radiation?
Okay, that's our last one. Now, can you give me an element that undergoes gamma radiation?
Argon?
Okay, so argon has a mass number of 40 and then an atomic number of 18. And then so with gamma radiation, nothing changes. So the particle still stays with the mass number of 40 and the atomic number of 18 in argon, but it releases a gamma particle, which you write with the Greek letter gamma. Okay, so with fission, you have a really big nucleus like this. Then you have a neutron. So what happens is the neutron bombards the really big nucleus. Then what happens is you form two really separate ones.
Oh, cool. Isn't this what happened with the atomic bomb?
Yeah, that's what happened. An atomic bomb is a really big chain reaction.
So what about fusion?
Okay, so in fusion, you have two smaller nuclei like these. And then they hit each other, and then you form a bigger one.
So what's a common everyday example of fusion?
In the sun uses fusion every day to keep its core burning.
So Mom, how can you predict the behavior of an unstable radioactive isotope?
Oh, you just use the band of stability. So here is the band of stability, and that is all, and if the elements fall in this ratio between the number of protons and neutrons, then they're stable and they won't radioactively decay. But if you have, let's say, one up here, then and it has too many protons and too many neutrons, you know it's alpha decay. And if it's here, which means it has too many neutrons, that means it's beta decay. And then if it's here, that means it has too many protons and not enough neutrons, so then it's either positron decay or electron capture.
So does this mean I get to go to Monica's concert now?
No, there's still a couple more things you have to know. So one thing about radioactive decay is its level of penetration. So with alpha decay, with alpha radiation, that can be stopped by a sheet of paper. With beta decay, the beta particle can be stopped by a sheet of aluminum foil. But then gamma radiation, which is the most dangerous, you need a piece of concrete or like a lead. That's really thick because it's really penetrating.
Hey, thanks, Mommy. I'm so happy I can finally go to the concert.
Hi everyone, my name is Monica, and I am going to be doing a concert for you about radioactive decay. Yeah. Unstable with a short half-life emitting particles. Get more stable. We are so strong. Nuclear forces flowing which make up nucleons. Tell me why it ain't nothing but some Tell me why it ain't nothing but some Tell me why I never wanna see you. Nucleus feeling.
I'm waking up to ash and dust. I wipe my brow and I sweat my rust. I'm breathing in the chemicals.